Now that we learned what sessions and cookies are, and we had our dummy authentication flow in place, let's dive into real authentication. This means that in this module, we'll add a functionality that allows users to sign up, to sign in, and we'll make sure that some resources can really only be accessed by users who are signed in, and that we're not just hiding the menu options, but that we really lock down access. I will also show you how to store passwords securely and so on. So what exactly is inside of this module? Well, first of all, we'll have a look at what exactly authentication is, how it works in a Node application or in a web application in general, because this is actually not limited to Node.js. Authentication would be implemented like this in a PHP app in the same way and in all the other languages too. We'll have a look at how we can store and use the credentials, so the email and password with which the user signed up. And I will dive into protecting routes. That is what I meant with locking down access, to make sure that users are only able to access the routes they need to access, and that we don't just hide the menu options, but that we really check the permissions on the server side. So what is authentication? Well, we obviously got our user using our application, interacting with our views, and we get the server and also the database with which our server works. These are all things we worked with in this course already. Now, in our application, we might have different routes, different actions a user can do. We might be able to view all products, to create and manage products, or to place orders. Now, obviously, we can do more things in our application, but these are just some examples. Now, the idea behind authentication is that not all these actions are available to every user of our application. And now here's one important thing. With user, I don't mean logged in user. I mean simply a person visiting our page, visiting localhost 3000 in our case here. Later, of course, the domain under which we deployed it. So I'm not talking about logged in users, but really just people using our page. And such anonymous users who are not logged in should not be able to do all these things. They certainly should be able to view all products, just as you are able to view all products on Amazon.com, even if you're not logged in. We want to allow this in our shop too. But there are other things, like for example here, creating products, managing products, and placing orders, which should only be available to logged in users and not to every visitor of our page. Because in order to buy a product, you need to be logged in. And in order to create a new product, you also need to be logged in. Because in our application, we of course connect a product to the logged in user. We match the two things. And this is what we need authentication for. We need to be able to differentiate between anonymous users who are not logged in and logged in users. And we need to provide a flow, a view, and the backend logic that allows people visiting our page to sign up and then to sign in. And then we can use sessions, as I showed it to you in the last module, to store the information whether a user is signed in and, well, let him interact with the page across requests. This is the idea behind authentication. Now, how is it implemented? How is authentication implemented? Same setup, we get a user, we get our backend, the server-side code in the database. And now typically, a user will send a login request. Now, obviously for that, a user, a visitor of our page, needs to have signed up before. But after you signed up, you can log in with your email and password. And on the server, we check whether that email and password combination is valid, whether we have a user with that email and that password in our database. If that is the case, we create a session for this user, and you learned how this works in the last module, and this session then identifies this user. This is required because otherwise, without a session, even if we find out that the credentials are valid, for the very next request, the user would be logged out again. Because remember, requests interact separated from each other. They don't know anything about each other. We need a session to connect them. That is why we create one with the user or the authentication information. We then return a 200 response, so basically a success response, and we obviously also store the cookie belonging to that session on the client. We return that with that response so that we really establish this session. And thereafter, the user is able to visit our restricted routes because now this cookie is sent with every request. On the server, we can connect this cookie to a session, and in the session, we have the information whether that user is signed in or not. And if the user is signed in, we can grant access to certain resources. This is how authentication is implemented in any web application that renders views. We'll learn a different way of adding authentication later when we work with REST and GraphQL APIs. But for a traditional web app, as we are building it here, where we do render EJS or handlebars or whatever templating engine you use, where we render such views, there we will use this session-based authentication approach. So let's dive back into our project and make sure you are logged out and make sure you download the attached snapshot, because there I did add a sign up link to our navigation bar, and if you click on that, we also load a sign up page. Whoops, where we should edit the caption of the button, by the way. So if you download the attached code, what was added, and you can also add this to your own project. I did add the sign up EJS file, where I also should change this to sign up. So you can simply add that file to your auth folder. I did manipulate or change the navigation EJS file. There, what I did add is I simply added the sign up navigation menu entry after login, both for the normal menu and also for the mobile menu down there. So basically one list item was added to each menu. This is what I added in this file. And then I worked on my routes. There I added 2 new routes, post sign up and get sign up, where I use my auth controller get sign up and post sign up actions. And in that controller, I worked on these actions. I added post sign up, which is an empty placeholder, nothing in there. So that is not that difficult. Get sign up also is a pretty simple route. There I simply render the auth sign up view. So you can just add this to your existing project or use my attached snapshot and replace my MongoDB URL with yours. And once you got all that, you should be able to have a running application that looks like this with a sign up page that looks like this, because now we will use or we will need a way of signing up users. So let's now start implementing the full authentication flow in this module. And for that, we'll first of all make sure that we can create new users, then that we can sign users in and sign users out, of course, that we can then use the information whether a user is signed in or signed out in all our views, and that we can protect our routes on the server side too. Because right now, even if I'm not signed in, what I can do is I can manually visit admin add product, and this works. So I can't get there by menu because we hide the menu options, but manually visiting this works. And this is also something we'll work on in this module. So let's get there step by step, and let's start by adding user sign up in the next lecture. So here I got a very simple sign up form, which is a pretty typical sign up form though. You have to enter an email, you have to enter a password, confirm the password, and click sign up. Now in that sign up view, I changed my button label, and there I also want to point at the sign up route in the action now. /sign up, send a post request to reach that post sign up route here, which ultimately triggers the post sign up action. Now, in this action, we want to store a new user in the database. Now, which steps does this include? Well, obviously, we want to extract the information from the incoming request. We want to read the email from the request body email field, and make sure you check your view how these inputs are named, because you retrieve the values on request body by these names. So email, password, and confirm password in my case. So request body email should work. Here I will have request body password to retrieve the password. And then I will also retrieve my confirm password here from confirm password. So these are the 3 values that should reach this route. Now, typically, what we would do first is we would validate the user input. So for example, we would check, is this a valid email address, and do password and confirm password match? And we will do this in this course too. But actually, I will have a complete module where I dive into how to validate user input, because you can, of course, do a lot of cool things when it comes to that, and therefore I dedicate a whole module to that. For now, we'll ignore this, and that means for now, you, of course, don't have to enter a valid email, and you don't have to enter a valid password. You don't have to confirm it either, but of course, you should do all that to have a realistic testing environment. We'll add validation later. We still need the values here, at least the first two. Because the next step is that we create a new user. Or actually, there's one step we want to do before we create a new user. Do you know which step that could be? Well, we want to find out if a user with that email already exists, because there should not be any duplicate emails in our database. For that, we actually can do two things. When using MongoDB, you could create an index in the Mongo database on your email field and give that index the unique property. Now, this is something you can do if you know how MongoDB works, if you got a little bit more experience with it, which you can get with my MongoDB course. There I do show this scenario, for example, but this is only one option of achieving this. An alternative is that you simply try to find a user with that email. So for that, we'll use our user model, which is, of course, a Mongoose user model. And there we can find a user. We can find one user because we already know we don't want to create a user with that email if we find only one user who already has that email. And we find that one user by passing a filter with these curly braces. And we'll look for the email field in our collection, so in the documents in our collection, and see if we find a user where the email field holds a value equal to the email we're extracting here. So right side of the colon is the email we're extracting, left side is the field we're looking for in the database. Now, here we get back, or we can call then to find out if this worked. We also might get an error, which I'll simply log here then. And in then, I will get my user object, so my user document, you could say. You can name this however you want. Now, we know that if user doc exists, so if this is not undefined, then we do have a user, and if we do have a user, then I certainly don't want to create a new one with the same email. So if this exists, I will actually return a response, and I will redirect back to /signup to inform the user that this did not work. Right now, not much informing is going on, as you can tell. We just redirect without showing an error message. This is also something which I'll show you how to better solve this, how to show error messages to the user. For now, we'll just redirect back to the sign up page and will not create a new user. If we make it past this check, we know that no user with that email exists yet, and therefore we can create a new one. So what we can do here then is we can create a new user object with new user, and we configure our new user. And there we store the email we're retrieving here, and we'll store the password. I like this for now. One important thing, in the user model there, right now I have a name and an email and no password. So I will change the user model. I don't really want to store a name. You could do that, but I'll not do it here. But instead, I will store a password for the user, which will be of type string and which will absolutely be required like this. So my user model changed slightly here. Now with that change in the user model, if we go back to our post sign up action, I can create a user like this. We can also add a card here. The card by default will be an object where items is equal to an empty array like this. And this is now a valid new user, which we can save in the database by calling save, as you learned. And then I can return this so that we can chain another then block here, which will be called once this save action completed. So this function here will be executed once saving is done. And here we can then redirect to, let's say, the starting page, because here we then know the user did sign up. Or to be precise, let's redirect to the login page, because after signing up, you need to log in. So this should now be an authentication flow that does check for the existence of a user and then create a new user. I'll quickly also go to my app.js file, and at the very bottom here, where I always create a new user if we don't have one yet, I will get rid of that code because now we have a real user creation flow, so we don't need the dummy user anymore. And I will also head over to Compass, which I'll start to connect to my Mongo database again. And in the connected database server, if we have a look at the shop database, in users, we obviously have one user, the dummy user we used before. Now let's delete that user now. We don't need it anymore. And with all these changes and all these files saved, let's reload the sign up page. And now let's try creating a new user with a dummy email, dummy password. You don't really need to enter a confirm password because we're not checking this anyways, and click sign up. Now this is looking good because I'm on the login page, so I was redirected. I also have no server error. If I now reload my users collection in MongoDB, in Compass, I also see this is a user with the credentials I added. So we did add a new user, but we have a huge problem with that user. Can you identify it? We'll fix it in the next lecture. We did add a basic authentication flow or a sign-up flow in the last lecture, but we have one huge security flaw in our current approach. Do you know which flaw that is? Well, we can see it in this line when we store a password. We're storing the password in plain text. And we can see that here in Compass. This is the password I entered, and it's stored in plain text. Now, this is not how you should do it, because if your database gets compromised, which you of course want to avoid, but if it happens, or if some employee of your company has the rights to look into it, your user passwords are fully exposed. So what we should do is we should encrypt that password. We should hash it in a way that is not reversible, where people cannot construct the password from. So that even if you get access to the database, you might be able to see the email, but you're not able to see the password, the real password that belongs to the email. This is something you should implement, and this is something we will implement now. And for this, we'll install another package. So I'll quit my server with Ctrl-C and install the package with npm install --save. And the name of the package is bcrypt.js, written like this. This is a package that helps us with encryption, and that will help us with encrypting the password. Now, once this was installed, we can restart our server with npm start. And now in the auth controller here, we can use bcrypt. So here I will add an import at the top, and I'll name it bcrypt. The name is up to you. And I'll require bcrypt.js like this, so the package we just installed. With it installed, let's head over to post sign up here. And here, instead of storing the password like this, I will store a hashed password. For this, right before I create my user, I'll use the bcrypt package which I installed and which I imported here. And I will call the hash method. The hash method as a first value takes the string which you want to hash. So in our case, the password. So we'll pass password here. The second argument then is the salt value. Now this is simply specifying how many rounds of hashing will be applied, you could say. And the higher the value, the longer it will take, but the more secure it will be. Currently a value of 12 is accepted as highly secure. Now this will generate a hash password, but this is an asynchronous task, and therefore this actually gives us back a promise. So I will return this so that I can chain another then call, a then block, where I will get my hashed password as an argument once it's done. So this function here will be called once the hashing is done. And therefore the user creation will go into this then block. And there I have the hashed password available, and the hashed password is what I'll store here. And with that, we dramatically improve the performance. Because now, if I do sign up again, first of all, let's use a different email, otherwise it should fail. We can test this in a second too. So I use a different email. If I sign up now, and I look into my collection, this is the new user, and this is of course not the password I entered. This is the hashed value. And the important thing is, you can't reconstruct the password I used. You can't decrypt this. This is also the reason why we don't encrypt the email, because we won't be able to decrypt this. I will still show you how we can then find out if the user entered a correct password, but we can't decrypt it. So if we need to send messages to that email, that would not work if we encrypt the email as well, because we could not reword that. So we need to store the email like this, but the password is secured. It's not readable. So this is how we should store it. And now I will get rid of my other user, but not before testing whether that works. So if I try to create a user with that same email again, I'm redirected to sign up. So I don't see an error message because I didn't add anything that would show such a message, but it seems to fail here. That is good. So for now, we can't create a new user with the same credentials. Let's now get rid of this one with the insecure password and continue with the one with the secure password. One quick word about my current setup here, by the way. Since I return my redirect to sign up here, and we do this in a then block, this will actually redirect, this is correct, but it will still execute the next then block. This is how promises work. So this code execution in this function does finish because I return, but the overall code execution does not, and therefore we reach the next then block even if we redirect. And that is why we get this password is required error when we use an existing email, because we reach this then block and the function in there, but hashed password will be undefined here because since we return after redirecting, we never execute the hash function. So we reach this function without the hashed password, and this is why we get this error. So the result is the same, but if you want to avoid this, what you can do is you can take that code and actually chain it in here. So have a nested promise. Instead of one promise chain with multiple then blocks, we will end after this then block if we redirect. There only is the catch block here for catching errors, of which we don't have one. And then the other then blocks here are only executed if we make it into the hashing mode. That is a tiny improvement that logically makes more sense here. Now that we are able to sign up, let's also add some functionality to ensure that we can sign in. And for that, we obviously have our login page. And when we enter something here, we reach our post login route here. Now in there, we still have the old dummy code where we just find our default user, which by the way won't exist anymore because we deleted it, and then we would create a session. This is obviously not the approach I want to use anymore. Instead, what I want to do is I want to find a user in here, but I want to find a user by the email the user entered. So let's first of all extract that. Let's extract the email from the request body, and let's extract the password from the request body. These are the two pieces of information I need for assigning a user in. And then here, I'll not use find by ID, but find one to find one user with a specific email. And there should be only one user with an email in the database. And I'll find the user by looking for the email field in the documents and comparing it to the email value we are extracting here. Now, if I find a user here, so if I make it into here and I then have a user, then I know that we can check the password next. If I don't have a user here, so if user is undefined, I didn't find a user in the database, and then I can simply return here, not execute the other code, and simply redirect back to login for now. Because the login failed, because we tried to use an email which does not exist in the database, as we didn't find a user for it. If we make it past this if check, we know that the email exists, but now we need to validate the password, of course. We'll do this with the bcrypt package again, because the password is of course stored in a hashed form. And I mentioned that we can't reverse this. So how can we now compare the password? Well, remember that bcrypt was responsible for creating the hash. Bcrypt uses a certain algorithm for that, and we can essentially pass the password the user entered into bcrypt and let bcrypt compare it to the hashed value. And bcrypt can then find out if the hashed value does make sense, taking into account the algorithm it used for creating that, for the password you entered as plain text. So if that plain text password, if you would hash it, could result in the hashed password. And if the answer is true, then you know the user entered a valid password. And for this, bcrypt has the compare function. And there we enter the password we want to check, so the password we extract from the incoming request, and then the hashed value against we want to compare it. And that is found in our user document, which we get from the database, and there, of course, in the password field. Now, this also returns a promise. So here we can add then and a catch block. Now, if we have an error here, so if we fail to compare this, then I also want to redirect back to the login page. But if we make it into the then block, then I want to check whether we were successful. Now, important, with compare, we'll only face an error if something goes wrong, not if the passwords do not match. In both a matching and a non-matching case, we make it into the then block. And result will be a boolean that is true if the passwords are equal. So we could also name this do match to make this clearer. And it will be false if they are not equal. So here we can check if do match is true. That means the passwords are equal. The user entered a valid password. And then we could return to not execute any other code. We could return a redirect to the starting page. If we don't make it into there, then we want to redirect back to the login page, because then the user entered an invalid password. Now we also want to set a session as we did it before. And that session code should only be set if we have a matching password. So if the user did authenticate. Then we can still set is logged in. We can still store the user in the session because we still need the user object. And the user here, keep in mind, is the user we retrieved from the database. And we want to save that session and only redirect in that session after we saved it successfully. Therefore, we should also return this to avoid code execution of this line, because the callback here will execute asynchronously. So this needs to be returned to not execute this line here. In here, we don't need to return then, because after this line can't be reached because this line isn't a callback in a different function. So with all that in place, we should be able to sign in if we do enter a valid password. Let's give this a try. So keep in mind, my email is test2, and I used tester as a password. And first of all, I will try a wrong email. I'm redirected back to login, so this didn't seem to succeed. We can also quickly go to the sessions and clear all sessions here so that we can really prove that no session was created. So now let me enter a valid email, but an incorrect password. And I'm again redirected back, and no session was created here. But now, let me enter the valid email and the valid password. And now I'm on the starting page. I see all options, which is looking good. We got no error here. And if I have a look at my sessions collection, we got a session here. Because now I am logged in. This is the user object with which I'm logged in, so this is correct. And now we got a working login flow, taking into account our email and so on. Now that we are able to sign up and sign in, we have to work on route protection. We already have a setup where we only show the menu options we should be able to interact with. But even when I log out, and therefore my session is gone, even when I do that, I can still manually enter admin, add product, and reach that page. And I could even try to create a product here. I would fail then, because there would be no user object on the backend where I try to get the logged in user. But this is not the user experience we want to offer. We don't even want to be able to load this page if we're not logged in. And for that, we need to protect our routes. Now, how do we protect routes? Well, to protect routes, we want to check whether the user is authenticated before we render back, let's say, the add product page. So in admin and the admin controller, in get add product, which loads that page, before we render that page, I want to check if in the request session is logged in is set. And to be precise, I want to check if it's not set. Because if this is not true, the user is not logged in. And if the user is not logged in, then I want to redirect, let's say, to the login page like this. So then, since I return here, this code will not execute and I won't load the added product page. So now let me try to reload this page. Keep in mind, I'm not logged in. and I'm on the login page. So this works, I am redirected here because session logged in is not set. On the other hand, if I do log in now, so if I do enter my valid credentials here, and I try to access add product, this does work because now I make it past this if check. Now this is a code we could add to every route which we want to protect, but adding it like this is a bit cumbersome. So let me show you a better way of protecting our routes, or a more scalable way, in the next lecture. As I mentioned in the last lecture, we could protect our routes like this, but this is not really a scalable way. We would have to add it to every route which should be protected, to every controller action. So instead, I want to create my own middleware, which I can add on every route that should be protected. And for this, I'll first of all create a brand new folder in my project here. So in the root of the project, I'll add a middleware folder. You could name this however you want. It doesn't have to be named middleware. In there, I'll add a is_of.js file, and you can also name that file however you want. And I will simply export a function here, a typical middleware function where you get request, response, and next, and then you execute some code. So I want to export such a function here. Now in that function, I'll simply implement the code I showed you in the last lecture. So I check if we are not logged in. And if that is the case, then I will return res redirect login like that. Otherwise, I'll call next, because otherwise I want to allow the request to continue to whichever route the request wanted to go to. Now this is the same logic as before, but it's wrapped in a middleware. Now we can go to the routes folder, and there you can actually add as many handlers for any route you want, and the request will be funneled through them from left to right. This means that in here I can now import my is_of middleware by requiring it from my middleware folder is_of like this. And is_of can now simply be added as an argument to get. And you can add as many arguments as you want, as many handlers as you want, therefore. And as I mentioned, they will be parsed from left to right. The request will travel through them from left to right. So the request which reaches add product goes into that is_of middleware first. And in the is_of middleware, we might be redirecting, and we don't call next. Hence, the request would never continue to that controller action. But if we make it past the if check here in the middleware, we do call next, so the next middleware inline will be called, and the next middleware inline would be our getAddProduct controller action here. And this means that we can now add this is_of middleware to all the routes here, because these routes actually all require authentication. And in the shop.js file, there also are some routes that should be protected. So I'll import is_of here too by requiring it from the middleware folder like this. And then there too, I want to protect getCard because you need to be authenticated to have a card. I will protect postcard. I will protect deleting a card item, posting an order, and viewing the orders. So all that is protected with the help of is_of. So now this means that if you're not logged in, you actually can't access these routes. I am not logged in here. Now let me show this to you and let me log out. And now I'll try to access admin add product. And you see I end up on the login page. And the same if I try to access cart. I end up on the login page. I can visit products and the details and so on, but I can't visit the rest. So now we have route protection in place, and we don't just hide the menu items here, but we really check the authentication status with the help of the session on the server side, and there the user has no way of manipulating it. So now we ensure that some routes, some methods are only available to logged in users. And indeed, if I do log in again, I can of course add a new book here, for example, with that same image we reused a couple of times, but it's still new. So let's add this, this works. So all of that can be done. All of that is supported here. You see we can edit a product. We can also delete a product if we want to. This all works, but we protect it against unauthenticated access. Now that we have our authentication flow and route protection in place, let's talk about security, and there about CSRF attacks. CSRF stands for cross-site request forgery. Now what is this? This is a special kind of attack pattern or approach where people can abuse your sessions and trick users of your application to execute malicious code. This is how it works. You have a user in your application, and now let's assume this is a visitor who indeed is logged in. You have your server-side code and your database with which you interact. Now the user interacts with your front-end views, so the pages you render back, and you get a session for that user and of course the cookie that belongs to that session. So everything you know. Now the user can do intended things, like for example, send money to B if you're building a banking app, or in our application, order some products with his own shipping address if we had such a checkout process. Now, in a CSRF attack scenario, your user is tricked onto a fake site. And this can be done, for example, by sending a link in an email. That site can look like your own page, but it technically is a different one. Now, on that site, there could be a link leading to your page, to your real page, executing some request there. Of course, you could include a form, for example, which sends a post request to your page, so to your own Node server, where you added some fields to send money to another person, to C in this case instead of B. To the user, this is pretty invisible because he saw a page that maybe looked like your page or clicked on a link that instantly redirected to your page, but with, behind the scenes, some data being sent there that does something the user would not want to do normally. Now, why does it work? Well, since you got a valid session for that user, if you send something to your site, to your servers, your session is used for that user. And therefore, that behind the scenes data that the user never sees, that configures the money transferal or the order in a certain way that is not okay to the user, this part is invisible to the user, but the valid session gets used for it because your server is used, and therefore this is accepted. This is an attack pattern where the session can be stolen, so to say, where you can abuse the fact that users are logged in and you can simply trick them into making requests which they might not even notice. Now, obviously, we want to protect against this attack pattern. And how can we protect now? Well, the idea is that we want to ensure that people can only use your session if they are working with your views. So with the views rendered by your application. So that the session is not available on any fake pages that might look like your page, but that aren't your page. And to ensure this, to add this feature, we will use a so-called CSRF token. Now let me show you how this works in the next lecture. So CSRF protection is an important thing. And to support that or to add it to the app, I'll quit my server and I'll install another package with npm install --save. The name of the package is csurf. This is a package for Node Express which allows us to generate a so-called CSRF token. Basically a token, a string value, we can embed into our forms, so into our pages, for every request that does something on the backend that changes the user's state. So anything like ordering something, anything that does something sensitive, which we want to protect against. We can include such a token in our views then, and on the server, this package will check if the incoming request does have that valid token. Now, how does this protect us? Well, the fake sites might send a request to your backend, and they could theoretically use your session therefore, but the requests will be missing the token, and they can't guess the token because it's a random hashed value, and only one value is valid, of course, and the package here which runs on the server, determines whether a token is valid. So they can't guess it, and they also can't steal it, because a new token is generated for every page you render. So with the package installed, let's rerun npm start, and let's use that cserf package. And how do we use it? To enable CSRF protection, we go to our app.js file, and in there, first of all, at the top, let's import this package. I'll name the constant CSRF, and I'll require the cserf package. Please note, the package is named cserf. The attack pattern is CSRF. That is why I named the constant like this. You can name it however you want, of course. Now we can create a new constant where we initialize this, you could say. So down there maybe, where we initialize some other things too. I'll initialize my CSRF protection by executing CSRF as a function. Now you can pass an object here where you can configure some things. For example, that you want to store the secret that is used for signing your tokens, so for hashing them, that you want to store that in the cookie instead of the session, which is the default. But I want to use the session, the default. And we also don't need to set any of the other values. You can dive into the official docs of that package to learn more, but the default settings should work fine. So with that, we get this CSRF protection middleware here. And we now just have to use that as a middleware. So here, after we initialize the session, that's important because CSRF, the package, will use that session now. After we initialize the session, I'll add CSRF protection. So basically the constant which holds my created middleware here. So now with that, CSRF protection is generally enabled, but we still need to add something to our views to really use it. Right now, if I save this and I go back to my app, and I reload this page, this works. If I go to orders, this works. If I log out, this fails. I get an invalid CSRF token here. And this is already showing us what we have to do in general. It failed here because that logout action here actually was a post request. And for any non-get requests, because you change data via post requests typically, for any such requests, this package will look for the existence of a CSRF token in your views, in the request, basically, in the request body. Now, to make sure that such a token is there, we first of all need to ensure we have it available in our views. To do that, we have to pass data into our view. So let's say I'm on the starting page, /nothing. So in the controller actions, that is my get index action, this one. Now here, we would have to pass a new piece of information into the render method. You could name it CSRF token, that name is up to you. And you get it from request, and then there will be a CSRF token method. This method is provided by the CSRF middleware, which we added by this package. So now this will generate such a token and will store it in CSRF token, which we then can use in our view. And there we could use it, for example, in the navigation, where I have my logout button form. In there, we would have to add an input, which is hidden so that no real input is rendered, but where the value now is a value we output with the help of EJS. And that value here will be our CSRF token. And the name here is just the field I'm storing that token in when rendering that view. This field, CSRF token. With that, if I reload this page, let's inspect the logout button here in the developer tools. And let's make sure that in the navigation EJS file, we don't just add it to the mobile logout button, but also in the other menu here. So with that changed, let me reload this. And now when inspecting that logout button, you will see that there we also have that input with a value of this token. And this here is the CSRF token which was generated by the package. If I now click on logout, I still get an error here though. The reason for that is that my package CSRF does not know that this hidden input contains my token. It's just a hidden input without any name. So what we have to do is we also have to give this a name. And here important, the name has to be _CSRF. Because the package which we added will look for this name. So for an input with that name. And the same, of course, should be done here in the mobile login button. Now with that, if we reload this view, if I click logout, now it works because now the package is able to extract that CSRF token. It also finds out that the token is valid, and therefore it allows us to proceed. So now it's not just the session that matters, but also the existence of this token. Now we can add this to all our render functions because we need it in all our routes, but that would be a bit cumbersome. So let me show you an easier way of getting data like this, or also is authenticated, into every page we render and not just some. So we added CSRF token protection, but it will only work if we are visiting our getIndex page. Now we want to have such a token, and by the way also our authentication status on every page we render. What we can do to get it onto every page is we can remove it from our render function here and instead tell Express.js, and this is now totally unrelated from the CSRF thing, tell Express.js that we have some data that should be included in every rendered view. We'll do this in the app.js file, and there, after this middleware where we extract the user, but before all our routes, I'll add another middleware, a normal middleware with our normal middleware function with the free arguments. And in there, we can use a special feature provided by Express.js. We can access a special field on the response, the locals field. This allows us to set local variables that are passed into the views. Local simply because, well, they will only exist in the views which are rendered. So there we can add our isAuthenticated property, which I removed from the render function, where I access request session is logged in. And I can also add my CSRF token variable, which I get from request CSRF token from this function. So now for every request that is executed, these two fields will be set for the views that are rendered. And then we have to call next so that we are able to continue. With this, if we go back and we reload this page, seems to work. And now let's also try signing in, where we also have a post request. And now this fails. And now do you know why? Well, because I do pass my token into all views, but in the views, I still need to use it. So for that, we have to repeat the code we added to the navigation. We need that hidden input with that name and that value, and we have to add it into all our forms. And that is something you just have to do. So for example, here in the add to cart post form, we need that hidden input with the CSRF token. And also in admin, added product. We need somewhere in that form that hidden token input. The same for our auth routes, of course. When logging in, we need that hidden input, and the same for signing up. This is required. In the products.js in the admin folder, there we also have a form for deleting a product. We need the token in there too. And in the shop, in the cart, we also have a delete cart item button. We need the hidden input there as well. And also down there for the order now button. This also sends a post request, and we need our hidden input there, our CSRF token. On index.js, we don't need it. In add to cart, I just added it, so there we already have it. In the product list page, it's the same. It was added to add to cart. And on the product detail page, I also only have add to cart. On the orders page here, we also have no post form. So now we should have this token everywhere where we need it. And if you save all that, and you now go back to your, let's say, starting page, and you visit the login page, and you do log in, this now works because we have that token. We also can add items to the cart. We can also order them. Well, there is an error, which we'll fix in a second. So for now, let's not order them, but let's delete them. This works. And generally, this works. Now let me fix this bug here, which is not related to the CSRF token, in the next lecture real quick. But this hopefully, and that is the main takeaway here, shows you how to use CSRF protection. And this is a crucial thing which you have to add to any production-ready application. It's not optional. Otherwise, you'll have a huge security issue on your page. You need to add this to ensure that your sessions don't get stolen. So now that the CSRF protection was added, let me quickly fix that error where I was not able to order an item. And there, path username is required is the issue which is thrown. Let's quickly check the shop controller and their post order. And in there, I indeed store the username, and I'm not storing the username anymore here. When signing up, users only have the email. So here, we could store the email for our user with request user email on the order, like this. So instead of the name, I now store the email of the user in here, or you also omit this and just store a user ID, whatever you want. Now, in our order model, this means that here I also don't expect the name, but the email, which still is a string and still is required. So this is a tiny change that needs to be done to fix that issue. And if I now go back to products and I add this to my cart, and I add it to my cart again, let's say, therefore I have 2, and I order this, now this works, and the cart is empty. So this was just a little note, something that was required. Let's log out. This all works. This is this bug fixed. We got all the core features that are related to authentication implemented. Now I want to work on the user experience, a little bit at least. Right now, when we log in and we, for example, try to log in with invalid credentials, where we don't find the email or the password does not match, or we try to create a user for whom the email already exists, then we are just redirected without any error message being shown on the page. Now, I will dive deeper into how to validate user input in the validation module of the course. But here, we're not talking about validation so much, but really about giving some feedback to the user in general. Now, when rendering views with the render method, as we are doing it here, including data that should be rendered on the page was simple. By the way, is authenticated can be deleted here because we always include this as a local. That is the case for all our routes as a side note. So you can remove that is authenticated thing from all render methods. But this is not really what I wanted to do here. It's a little side thing we can do though. The main thing is that it's easy to pass data to our views inside of the render method, as you can see. It was never a problem to get our data into the views there. However, it is a huge problem if we want to pass some data into the rendered view when we are redirecting, as we are doing it here. Because upon a redirect, technically a new request is started. A new request to /login in this case. And on that new request, we don't know that we got here because the user entered an invalid email or anything like that. When we trigger this new request, this is treated in the same way as a request that was triggered by clicking on the login button in our menu. So we have no way of finding out if we want to display an error message or not. And hence in the render method of getLogin, where we show that login page, we don't know if we want to include some error message. Now, to solve that problem and store some data before we redirect, which we then use in the brand new request that is triggered by the redirect, how could we do that? Well, you learned if you want to store data across requests, you need a session. So we can use a session for that. But of course, I don't want to store the error message in the session permanently. I want to add something to the error message, kind of flash it onto the session. And once the error message was then used, so once we pulled it out of the session and did something with it, I want to remove it from the session so that for subsequent requests, this error message is not part of the session anymore. And for this, we can use another package, which makes this really easy. We installed it with npm install -- save, and then the package is called connect-flash. If you hit enter, this gets downloaded and added to your project. We can restart the server thereafter. And now connect-flash is really simple to use. First of all, we initialize it in our app.js folder, a file. In there, we install it or we import it just as we import other packages. You can store it in a constant, which you name however you want. I'll name it Flash. And I will require connect Flash here. Now, Flash then needs to be registered, you could say, initialized. I'll do this here at the bottom. You need to do it after you initialized the session, so certainly after this middleware. There, I will call use, and I will simply call Flash as a function here. Now we can use that Flash middleware anywhere in our application on the request object. So now, let's save that. Let's head over to Auth.js, and let's say here, when we're logging in, and we don't find a user with that email, which is the problem here, we want to flash an error message into our session. We do this now with request, and there will be a flash method now added by this package. This flash message now simply takes a key under which this message will be stored. We could name this error, and then the message. And in this case, this would be invalid email or password. Now, you could also say just invalid email. Some people advocate not being as clear as people can otherwise guess which part of the credentials was wrong. I'd argue they can test this anyways by trying to sign up with that email. But whatever you want, you can output or flash such an error message. Now, with that, it's in the session, and it's in there until we use it. Now, we want to use it here when we do render the login page. Here, I want to include error message variable, let's say. And that error message variable will simply pull that by using request flash again. And here, we now just access the key for which we want to get the message. So in my case, that key is what I specified here, error. So now I can pull that message out with error. So whatever I stored in error will now be retrieved and stored in error message. And thereafter, this information is removed from the session. So now error message will be set and will hold a value only if we have an error flashed into our session. And therefore, we can now move over to our view, to the login view, and display the error message here. Let's say above all of that, I add a div. And for now, let's make this really simple and just output our error message. So here, error message is the variable in which I'm storing it. Obviously, I want to check if that exists before I render this. So I will wrap this with some EJS if statement where I check if error message. This will not be treated as true if it's simply not defined. So if we simply are not able to retrieve anything. And then let's try to output it like this. Let's see if that works. If I go back to my application and I reload that login page, that seems to work. And now let me enter an invalid email. And indeed, I see invalid email or password. If I do enter a valid email, but an invalid password, I don't see that because there I don't flash anything onto my session yet. So this is working. Now let's quickly reformat that. I'll do that in the next lecture. You can skip it and download the finished formatted code if you want to. And thereafter, let's add this in other useful places too. I'm outputting that error message. I just want to style it a little bit now. And for that, I'll give it a CSS class and I'll simply name that user message and then maybe user message -- error using some BEM styling here. That's a CSS styling convention or a convention of naming your classes. Doesn't matter too much. You can name this however you want in the end. I added these two classes, one to have a general message look and then one for errors, because maybe we also want to be able to output success messages later. So with that, let me quickly add this to some CSS files. And you can skip this lecture if you want. In the next lecture, you find the finished code attached, which you can use. In the main CSS, I'll quickly add this. Let's say at the bottom of this file. It's up to you, right before the media query maybe. I have my user message, so this CSS class I just added here. And let's say such a user message should use a margin auto to be centered, get a width of 90% by default. I'll also set up some styling in case I'm on a bigger screen. There, user message will have a width of, let's say, 30 rem. And then here, I'll give it a border of 1 pixel solid. And let's use maybe some bluish color here. Maybe not that blue. Well, basically whichever blue color you want. Maybe this one. And a background color. I'll also use a blue here. Also a different blue. So some light bluish color here. So a general info message should have maybe some neutral colors. So some blue like this. And let's see how that looks like. With it added, let me try entering an invalid email again. Looks like that. No, not too pretty. That should be much lighter. I also want to have some padding in here, maybe 1 rem, and let's give it some rounded corners as well. And now with that, if we enter an invalid email, that looks much better. Okay, so now this is my general info message. Let's maybe also center the text if we want to. And now let's give this a error version basically with -- error. That's the other class I added to this specific box in my login screen. And there I will change the border color to be red. And the background should be a light red. So let's start with red and then turn this into a light red. And now if we try this again, now it looks like this. Okay, so this could be the error message we're outputting here. You could also turn the text red if you want. So you could also say text color should be red here maybe. And reduce the padding maybe to 0.5. That could look a bit better. So invalid email or password. That looks good. Now, I always have that stick around now. Reason for that is if I go back, error message seems to be set to something, even if we're not having a message in there. And that is something I'll check in the next lecture. So I added a message box in the last lecture. You can download the finished version of the entire project attached. I simply added CSS classes to my div, which surrounds the message. And then I worked on these classes in the main CSS file. I added user message and user message error, and also added some user message entry to my desktop size classes. So you can add this manually from the attached code. Now, one thing you'll notice is that even if you load the login page regularly, you see an empty box here. So even if no message is flashed, it looks like error message is not set to undefined. And therefore, let's quickly go to auth, and let's simply console log request flash error to see what's in there that's causing this to not be undefined, basically. So if I reload this page, I see it's an empty array. And if I do enter something here, you see it's an array of messages. So in the end, what we want to do is we want to extract our message here is equal to request flash error. Now, if message length is now greater than 0, then I know I have a message in there. So I'll now actually turn this into a variable by using let here, and then I can set message equal to message, the first element, because I want to retrieve that. Otherwise, I'll set message equal to null. And now down there, we can use the message and pass that as an error message. If we now save that, don't have the box here. If I do enter something invalid, we do see the error message though. But if I go to the login page regularly without an error, I don't see it. So this is now how we can use these flash messages and output them in a nice error box. Now here's also a challenge for you. Find some other places in the login and sign up screen where it would make sense to flash other messages onto the screen. We'll do it together in the next lecture. So were you successful? We added our flash message here when we used an email which we did not find. Now obviously if we have a password that does not match, here where we also redirect to login, I also want to flash my invalid email or password message onto the session. So this is another great place, because if we now save this, on the login screen, I might have a valid email, but an invalid password, and I get this error message. With valid credentials, it of course works fine though. Now we can also do something when signing up. Because when signing up, I'm checking whether an email address already exists. Well, before redirecting here, I can also output something there. Email exists already. Please pick a different one. Something like that. If we now save that, and I enter the email address which indeed does already exist, well, then I'm redirected without having any effect. And that makes sense because we flashed the message, but I'm not outputting it. So we need to go to the login page and copy that code for outputting an error message, and then go to sign up. And there, above the form, let's also output the error message here. But of course, for this to work, we also need to extract it when loading the sign up page. So that code which I'm using in getLogin to render my error message, I need that in getSignUp too. And then there, I also need to pass this error message variable to the view, which holds that message I'm extracting. Otherwise, we can't display it even though we flash it into the session. So now with that, let's try this again. Let's reuse a password, an email that already exists. And now I get this error. If I do create a valid user with a valid email, this works, however. So now, if we quickly check our users collection, we see that was added. So these are some messages I can flash onto the screen. You could add more. For example, after logging out, you could also output some confirmation for that. But this should do it for now. Was a nice practice and improves the user experience a little bit. So that's it for this module. I'll actually dive into some other authentication related things in the next modules. For example, we'll add password resetting, but these are the basic things you need to know about authentication. You learned what authentication means, that it means that not every visitor of your page can view and do everything, that authentication has to happen on the server side to ensure that users don't trick you into thinking they are authenticated, and that you therefore use sessions to store the authentication status, and that you can protect routes by checking that session-controlled login status right before the request reaches your controller action or the code in general that is executed in a route. Now, authentication obviously also is strongly tied to security and providing a good user experience. And therefore, passwords should absolutely be stored in a hashed form. If you store them in plain text, if your database gets compromised, the attackers have full access to your user accounts. Additionally, CSRF attacks, cross-site request forgery attacks, are a real issue because your session can be stolen there, so to say, and therefore you should implement CSRF protection as shown in this module in any production-ready app you're planning to ship. Now, for a better user experience, you can look into flashing data or messages, as we did it in this module, into your session store. Flashing means that this data will be removed from the session automatically by the package we used once we used the data. And we can use that data to persist data across redirects, because redirects technically trigger two different requests, or we have the old request, we redirect, and then a new request starts. And if we want to share data across requests, as you learned, we need to use a session. So these are the general authentication related things you need, and with this knowledge, you already get very, very far. Now in the next module, we'll have a look at how we can send mails from inside our Node application, because we'll need that feature to then enhance our application a little bit regarding the authentication, so that we can also add a password resetting mechanism. We'll do this in the module thereafter, but in the next module, let's first of all have a look at how we send mails.